we are seeing both of us are in the same city, but technically we are in two different parts of the cities because south of Bangalore and north of Bangalore look like two different cities. So transportation from one end to the other takes
Right.
forever. So glad that you could take time off and join us for this. And I think it will be a wonderful educative session for all of us because this is a very exciting topic. And many are looking forward to getting some insights in this developing field of science and technology. So I think we are right on dot at 3 o'clock. So we will start off now.
Sure.
So ladies and gentlemen, good afternoon to those who are in India and good morning to those who are joined us from the US and Europe, and good morning to Japan. Good evening to Japan, yes. So welcome to all of you to MIJSC at IIMB, Tatsujin Speak webinar lecture series. My name is Sai-B Pratnam. I am the Chief Operating Officer at MIJSC at IIMB. Mizuho India Japan Study Center. It's a long name, but this is basically a center of excellence which has been created at IIM Bangalore. And the focus of this center is to strengthen India and Japan bonds by promoting academic, industry, and societal linkages. So this webinar series is one such attempt wherein we are trying to bring in experts from both India and Japan to talk about societal, technological, business, and many other facets of life, which highlight both the Indian, Japanese, and a third-party perspective on the topic of discussion. In fact, this webinar series was started sometime in August of 2020, right in the thick of the coronavirus. And this is the 18th in the series. And we have been having it more or less monthly or bi-monthly. Today's session, we have Professor Puneet Rathod from Indian Institute of Science, Bangalore, who is also very young, but a very well-known researcher at IISc and also at Robert Bosch Center for Cyber Physical Systems, and as well as the Center for Infrastructure, Sustainable Transportation, and Urban Planning. So I have great pleasure today to welcome Dr. Puneet Rathod. Dr. Puneet has worked as a postdoc fellow in Sensible City Labs at MIT in the US and Grab NUS AI Lab at National University of Singapore. So you can see that credentials of Dr. Puneet is extremely high. He has completed his PhD from University of Melbourne in Australia only a few years ago, 3-4 years ago. But prior to that, also, he has worked as a researcher at Tata Steels in their automotive automation division, Jamshedpur, where he has developed several real-time systems based on machine learning, machine vision for manufacturing industries. Currently, of course, his research work has been, as I was mentioning before, internationally recognized. And recognition has come in many forms. He has got multiple best paper awards at world recognized IEEE conferences, and also the best thesis prizes by IEEE Systems Man and Cybernetic Society, popularly known as SMC, and also at Melbourne School of Engineering, which is, of course, University of Melbourne. His current research interests are in unsupervised learning, streaming, data analytics, urban mobility, analytics in urban mobility, and data-driven techniques for IoT, transportation, and autonomous systems. Welcome to this forum, sir. Before I hand over, I would discuss the theme for today's discussion: transportation revolution through AI or artificial intelligence. So the subtitle is really an advanced data science approach to mobility. So before I hand it over to him, I would like to just set the context for the discussion today. And as all of you know, every day, abundant amount of data is generated. So we have, in fact, some people call it the data diarrhea, where information or data comes from various sources, such as Internet of Things or IoT networks, smartphones, social network activities, and so on. How does one make sense of such unprecedented amount of data? That is a challenge in today's world, and it is essential for businesses, services, and almost every smart city domain, such as healthcare, transport, environment, and also the energy sectors. The data that is generated from these domains are generally, they are unlabeled. And as Professor Puneet calls it, spatio-temporal. And they are streaming. And they are also in very high dimension, which makes interpretation of these data a very, very challenging to do it. But it is important to create a useful knowledge for all of us. So in this talk, actually, Professor Puneet will provide us an overview of the advances in the data sciences that is leading to a virtual transportation revolution by the use of artificial intelligence tools. He would also discuss the social factors that would impact our society in the coming years or decades. This would be followed by a discussion between the two of us, where I will try to explore a little more deep into what he has given as an introduction. And finally, he is willing to answer Q&A from the audience. So my request to all of you, keep posting your questions on the chat box. And I, as a moderator, will be presenting them to Dr. Puneet at the end of our discussion. So over to you, sir, for giving us an overview of the current developments in this exciting and developing field.
Okay. Thank you, Mr. Saibit, for the nice introduction. And yeah, so maybe I'll start by sharing the screen, like my presentation, and then start giving some overview about the problems and the theme of the talk. So let me just share my screen. So
yes, we can see the screen.
I guess you can see the full screen.
Yes, we can see the full screen. Yes.
Yeah. So as you already introduced, just wanted to give some brief you can say highlight on the department. So although it appears from the name, it's enter, it's like a kind of department at ISC, with focus on the autonomous vehicles, UAVs, robotics, machine learning, security and privacy, and the stuff where the focus is mainly on transportation. So in this, I'll just give you a brief overview about the work that is going on in transportation in terms of AI and data analytics, the work that is going on at IISc, and the work that maybe few work that I have been doing in terms of AI in transportation. And then, of course, it will be followed by a discussion of the challenges. So, of course, first we need to know like what is the transportation, and when we talk about urban transportation, what does it mean? Right? So there exist several problems worldwide, especially in developing countries. If you talk about major cities in India, right? So the average travel distance and as well as the intensity of the traffic is continuously increasing in our cities due and causing traffic congestion. So according to a study, an efficient transportation sector in US alone significantly causes economically in terms of time, fuel, and money, and as well as environmentally, where 1/4 of the total greenhouse gas emission comes from transportation sector. So it's like a huge impact of the inefficient transportation problem. Some other important problems that we generally encounter, especially in India, like parking difficulties, air and noise pollution, where transportation sector alone contributes 25% of the total emission in major Indian cities. When I talk PM10 and PM2.5 in terms of that. Deteriorating road safety due to the poor traffic standards and practice, and underserved locations in many, like of course the public transportation is not very efficient in most of our cities, and many locations are underserved where we don't have any transportation, public transportation services, right? So these are major problems, although there are a few problems, but generally focus of the research and in developing countries are mainly on this. However, when we talk about these problems, to understand the influence or effect of different factors which are contributing to these problems, right, that require an in-depth study about the data in the transportation dynamics which causes these problems, right? And for that, we require data, a rich amount of data. So earlier, we used to get this data through surveys or some, few studies like we maybe through some smartphones and all, but nowadays it is possible to collect this huge amount of data, which can enable so many analytics which can answer the questions and help us to understand the effect of different factors for these problems. So the idea is we need rich and reliable transportation data or the data to study this kind of effects, right? So as we talk about AI and transportation, so as a general term or you can layman term, it is called as intelligent transportation system, where the intelligence is coming from the sensing infrastructure as well as the AI. So that's why it's very popular term here. So the main, you can say, pillar for this in ITS is the sensing infrastructure. So now with the wide prevalence of the GPS-enabled device, for example, smartphones, or nowadays many modern cars have inbuilt GPS devices, right? Sensor network, IoT and ICT technology, the revolution in the ICT and IoT, everyone's seen like so many low-cost sensors are available now. We can just buy and put it there, right? And most of the vehicles are now automatically connected or somehow automated, depending on the level of autonomy. So given the V2V and V2I communications, we have very good sensing infrastructure, which enables us to collect loads of data from here. And now it is easy. So the data, as you had mentioned, like it's called spatio-temporal data. The data is in both in space and time. So we are moving in space and of course in time. Right? So that's why it's called spatio-temporal data. And then generally the data which we collect is basically from the mobility. Right? We are moving, we are getting kind of mobility data, so which are time ordered, and in technical words in machine learning, they are called trajectories. You can say sequence of locations with some information. So let's say you might collect lots of data. You can collect noise, you can collect air quality, that called PM 10, PM 2.5, and so many things with the location information. So these are called trajectories. We also collect lots of telemetric data from the car itself or from the vehicle itself. Right? We have these vehicles, most of these vehicles have the CAN bus or what they call controlled in a network based systems, where they generate lots of data, and many automobile company uses data, or there are also standards which can make this data available to the third party if they want to analyze on this data. We also get data from government agencies, the municipalities, city councils, like ticketing data and some other data about the movement patterns of the passengers in the public transportation and all. So we get huge amount of data from different sources. So, of course, once we get the data, to make it intelligent, we need to make some intelligent algorithms to analyze this data. So that's where data analytics comes into the picture, where AI and ML plays a huge part. So one part is we have data in space and time. So if we apply data mining in space and time, these methods are known as spatial temporal data mining, which are again comes under a big umbrella of AI and ML. And recently, these deep learning or the neural networks techniques become very popular, and they are widely used in transportation sector to bring some revolutionary changes in terms of intelligence. And since these data are mostly time series, so these are kind of analytics which are generally done in machine learning sense. So I will just give a brief kind of AI fields, or you can say studies which are going on in the ITS. So the first is basically starts in the networks and controls. So of course we are in a transportation network. So when I say network, we have roads, you can say public stations, we have roads, intersections, so many things, transits and all. So it's kind of a network. So generally the problem we want to solve in road network is like the routing problem, where to go, from how to go from A to B in a given criteria. We want to go in a shortest path, we want to go in a shortest time, or maybe there can be some other factors. For example, you want to follow the path from A to B, which is more, you can say less polluted, right? So there can be several factors. So that's kind of a routing thing. How do we optimize? How do we find the best routing? So generally it works on the optimization problems, game theory, which actions to take, where to, which path to take, so that it gives us the maximum reward that we want. And the reward is nothing but we want to reduce the full fuel consumption. We want to reach somewhere very soon, right? So there can be several factors we can design our rewards. When you talk about the game theory and the optimization, there are some recent approaches come from the neural network. Basically, kind of you can say reinforcement learning, which are very popular techniques nowadays, and control theory, because control plays a huge play, like to control the dynamics, the network dynamics. Right? So these are the this is the one of the you can say also most important fields. Second is the demand forecasting. So we have so many public transportation services, buses, trains, right? So when we talk about public transportation, not only buses, trains, also we talk about aviation, shipping, and all, right? So one thing is we need to understand the demand. Where is the demand? What is the supply, right? So there may be some locations where there is a huge demand, but there is no proper supply of public transportation vehicles. Right? They are underserved locations, and there may be some certain areas where there is no supply but huge demand. So we need to understand the dynamics of this demand. So we need to understand what kind of transportation modes people use, whether they want to use public in a given area, maybe they want to use cars, or they are more comfortable with the public transportation, or they want to use bicycles. So it depends, depending on the behavior of the people, and somehow they are also affected by the social and demographic factors. So in India, depending on the culture, social factor, demographic factors, economic factors, these choices also significantly different. So that it requires kind of analysis, like how do we predict the demand, and based on this predicting the demand, we can take some decisions and make some policies according to that. How do we understand the travel behavior of the people? How do we understand the psychology, right? So these fields come in the demand forecasting research. Then the third comes in the traffic flow modeling. So we already have some traffic which is flowing on the roads, on the railway, air, right? So if you talk about modeling, you want to understand the driving behavior, how people, even the drivers are driving. Not only the driving, also the passengers or pedestrians, right? Not only car, even the bicycles. So how they are driving. So there are two types of driving. We call it microscopy and macroscopy. One, how we are behaving inside the car, and we are just affecting within our context. And one, how we are affecting others, or how we are affected by others' driving behavior. Right. So both comes into the picture. What are the human factors? And since we are not in the age like where completely have fully automatic vehicles, the human is still a significant part in our you can say transportation via their driving, right? So human factors plays a very important role. How whether they're distracted, they are dry, they are feeling drowsy, they are drunk, they are tired. So many things are there. How they are driving, right? So the human factors also play a very important role. Of course, not everything can be modeled in real world for the you can say by just collecting the data from the real world. It's not very easy task. So somehow simulator gives the flexibility to perform some experiment and study how drivers are driving or how the traffic flow is changing. So we can make use of simulator in the laboratory setting and understand the dynamics of the driving behavior and the traffic flow. And then nowadays we also have virtual reality or augmented reality kind of technologies where we can directly create a scenario and present it to the drivers and then study them how they are driving when we present the scenarios. Yeah, right. So these are the studies. And then we have in general, if we talk about AI ML, what kind of techniques are being popular in transportation. So lots of data, especially if you talk about self-driving cars, is in terms of videos. So whenever we have images or videos, computer vision plays a huge part in analyzing these kinds of data. And since many of these vehicles, connected vehicles, they are lots of sensors, and these sensors generate huge amount of data continuously coming in streams, heterogeneous. It's a big data. So how do we make some use of this data to generate some knowledge and some decision? So that's kind of big data analytics. Even NLP can be used like kind of natural language processing. The driver is driving, can we give some kind of feedback verbally, or can we generate some, you can say some alerts or some command in natural language so that driver can take some feedback from these alerts and then change the driving accordingly. Right? So NLP also huge work is being done. Distributed computing. Of course, when we have huge data, we can't afford to collect the data from the vehicle and send it to the cloud, and then from cloud and some offline system we analyze and then send it back to the driver. There are some latency issues. We need to process the data in real time. Wherever the data is being collected, process them there only. So that is called edge computing. So we have to put the system or the processor on the board itself in the vehicle, where the data processed on the vehicle or on the edge, and just to make you the data and give the decision or the output there itself. Visualization, which is also very important part, like in any AML, how we do analytics, but how do we present our output or what we want to show to the user? The visual interpretation is very important. With just numbers, it may not be easy for a general people or civilians because they are not experts. So we need to provide some information in a very proper visualization way. So that's also a very important research area or AIML area. And the last is explainable. So this most of the machine learning, of course, these if skilled person might understand a bit more, not common or simple human can't understand. So the model should be very explainable. If the model is saying you are driving wrong, it should also say how you are driving wrong, in what aspects you are driving wrong. So when you are taking some decision, you should tell which decisions you are not taking, which in what aspects you are doing it wrong, so that they can change their driving, something like that. So these are the main researches which are going on in ITS. And of course, when we talk about the transportation, it's not just the road transportation, but it includes public transportation, bicycles, first mile and the last mile, like there is a metro station, a bus station, how we reach from our home to the bus station or the public transportation station, which is the first mile. And then after the destination, how do we, after the end stop, how do we reach to our home or office? It's last mile. Shared mobility, right? How it's, and it's one of the future, like kind of future, electric vehicle is the future, shared mobility is the future. How can we allow people to share the rides and then reduce the number of cars on the road somehow by reducing the emissions on the road, right? Freight, logistics, which are also very important part of the transportation. And then nowadays, most of the research is also focusing on the UAVs and AGVs, unmanned aerial vehicles in the automated guided vehicles, right, the ground vehicles. So the focus in the research in the transportation is on these domains. So when we talk about the revolutionary applications in of AI in ITS, I guess when we talk about AI in ITS, the first thing only which comes to my mind is the self-driving cars. Everyone is talking about self-driving cars, right? So, and it's not a new thing. Let me tell you, it started in 1939 when General Motors came with the idea of self-driving car, which was kind of electric vehicle with some radio controlled electromagnetic field. and they conceptualized this self-driving car in 1958, where they use some kind of pickup coils to maneuver the driver. Still, human was there, but they use some pickup coils to change for the maneuvering purpose. And then after General Motors, the second country which started driving cars is the Japan. So Japanese started in 1977. They started the camera-based self-driving cars, and I guess they were very well ahead at that time. And the only limitation was that the maximum speed for those cars was 20 kilometers per hour. That was, but I guess for the 1977, it was a very good breakthrough, right? And now in this era, we are talking about the self-driving car where we are talking about level 3 or level 4 or maybe level 5 autonomy in future, right? So when I say level 1, 2, 3, 4, or 5 autonomy, that means we have hands on the car, we are hands off on the car. The level 3 is the eyes off from the car, and level 4 there is the driver, but no intervention of the driver, only in the emergency situation. And level 5 is the fully autonomy, no intervention of the driver. So it requires so much analytics. So the research are going on in this aspect. So where we require kind of analytics like 3D positioning. How do we position the vehicle and the road, both laterally and the longitudinally, right? How can we estimate the motion of the vehicle as well as the surrounding vehicle or the objects? How can we detect the pedestrian movement, their intent, where they want to do, what they want to do? Because these all things are important if you want to navigate the self-driving car without human intervention. Traffic lights, although it looks easy, or what is the problem with the traffic light detection, but there are so many ambient lights and it can be confused. And it's a problem of the life, right? So it's just problem if you detect one traffic light incorrect, it can cause fatality. So it's not like where we can just allow some kind of relaxation in the prediction. So they all require a very highly accurate models in these aspects before we put these cars in real world, right? So the research is going on this aspect. Then we have advanced driving assistance systems. This is what we call ADAS systems. So where we can assist the drivers by providing some feedback. So these researches are going on in many countries, even in India. I guess many companies, automobile companies, started doing researches in ADAS systems, which has several, you can say, components or kind of alerts. So like lane change detection when you're changing lane. Collision avoidance, it can give you alert for the forward collision if you are very near to the car or to the following car. It can also assist you for braking, for parking, and so on. So it provides several types of feedbacks and alerts to the drivers, and which can assist the car. So of course, it requires lots of data from many sensors, as you can see in this particular figure. Right? Then we have traffic management. As we know that many of these, especially in developing countries, this traffic congestion is a very serious problem. Especially if we talk Bangalore, it takes like 2 to 3 hours just from coming from airport to the IIC in like peak hour time. So congestion is a very significant problem, and not in India, also in many countries in the major cities. So we have to analyze the road congestion. So there will be many sensors, cameras, which are capturing the data, but how we make use of this data to analyze the congestion and provide some information to the councils and others. Can we suggest some alternative routes? Can we plan our city? Can we create better road networks? So the traffic management, I would say it's more of kind of current problem in the urban transportation, where AI can play a huge role. Then we have telematics. As I told, the vehicles now are collecting huge amount of data, which allow us to monitor the vehicles, their condition, how the vehicles are moving. It can offer some predictive maintenance. Can we predict whether the vehicle is going to be, some problem is going to be there in future, or can we predict some where it requires maintenance, right? Real-time information. So when you talk about a smart city in India, I guess the simple thing, can we track our public transportation in real time? Can we know like what is the current location of the particular bus in real time? We have the data, right? So the real-time information about the different vehicles is also important thing, right? The driving behavior, as I mentioned, from the data, can we predict driving behavior, how the drivers are driving? Are they safe driver or the aggressive driver? Right? How they're affecting, and not only in terms of driving, but also the in terms of vehicle performance or efficiency, because driving also causes the fuel consumption. Right? If you're not driving safely, you can say our driving will have to be putting so many times acceleration and braking, it will cause higher fuel consumption and safety. So lots of research also going on telemetrics kind of data analytics. Then parking also a very huge problem in terms of transportation. So data, you can use either camera data or some kind of the sensor data, which are on the ground, right? And can we analyze this data to have better space management? Can we create more space for this kind of car? Can we create efficient payment and the pricing solutions for the parking? Right? Or can we add some services? For example, we talk about electric vehicles in the transportation. Can we use this kind of, let's say if we create more space, can we use this space as the charging station for the electric vehicles? Right? So this allows lots of analytics and some kind of information that can give us by analyzing the data. And not only the vehicle, but also the infrastructure where these vehicles are, you can say, driving, right? So how is the condition of this infrastructure? If you talk about road network, so road condition, we talk about Bangalore road, so many potholes. Right? So we need to detect the quality of the roads, right? That there are potholes, some irregular surface, defective surface, road bumps are there. How, even if the roads are good, can we predict from the data? Okay, it requires maintenance now, right? So that allows lots of analytics. So with the sensors, these all can be detected. So these are the current applications where the future like research is going on, and they again kind of, if we get successful, it's kind of a revolution in the of AI in transportation, right? So these are basically kind of researches going on globally for AI in transportation. But so we talk about research activities in ITS at IISc Bangalore. So most of the problems that I mentioned before, of course, we are working on this problem. But given that India is a developing country, our focus is also on the real problem that are specific to India. Right. So, for example, bus bunching problem. Let's say some buses are delayed, so and some buses are on the time. Because of that, sometimes we see more buses together, and sometimes we don't see any buses at the right time, right? And that may cause buses together. That may also cause passenger, so many passengers together, right, at the station. So this is a very significant problem in India, all right? So how can we solve this bus bunching problem? How can we route the buses accordingly so that this problem doesn't occur? Can we predict the ridership forecasting, like how many people choose bus? How do we, how should we create the schedule for the bus and target so that they get proper connectivity, right? So as soon as they reach to the metro, they should be able to get the metro, right? So routing problems is very important in terms of public transportation. Then first and last mile. So as I mentioned, how you reach from your home to the station and how you reach from the station to your home or office where you want to go. Public transportation is there, but this thing still it requires some, let's say we take auto rickshaw or some bike, right? So how can we connect this private and the public player together so that we have smooth first mile and last mile connectivity with the public transportation, right? So how do we do it? This research going on. Optimization of parking lots. How can we create more parking spaces? How can we optimize so that it doesn't cause a traffic as well, right? We are talking about electric vehicles. One of the problems with electric vehicles that the charging infrastructure, right? So where do we put charging infrastructure? We need proper places. We also need to understand the dynamics, the electric consumption, the load of the electric consumption in the different areas, so that we can find out which are the best locations. So the operation and the planning of the electric charging fleets is also important, right? Then optimizing sensing potential. So can we use this public transportation vehicle as a sensor? So let's say if I put some sensors on the public buses, can I sense the whole Bangalore city? Let's say if I put some sensors on the buses, can I capture the air quality in whole Bangalore city? If yes, which buses we have to put the sensors? How many buses we need to put? So how can we optimize? How can we maximize the sensing capacity of the vehicles, of these public transport vehicles? That's another research. And then as I mentioned, ADAS system to understand driving behavior or give some alert to the driver so that you can reduce the traffic congestion, you can reduce the traffic accident, right, by providing the alert about the color. So that is the also research that we're doing. Driving behavior. Driving behavior study in US or Western countries is different than driving behavior in India, where we have heterogeneous and disorderly traffic streams, right? Because people don't follow the rules, indiscipline is there, infrastructure is compromised. So we have challenges, right? So, and then UAVs and AGVs, like how can we route the UAVs? How these multiple UAVs, the swarm can coordinate with each other if they want to monitor something, right? And how can we detect the objects on the UAVs on the fly in real time? So these are some of the researches which are going on at IISc. So when I talk about some of the research that I do, I will just briefly say, describe maybe two or three research that we have done or doing. Driving behavior. So one thing, people collect the data from the cars and do it. but maybe most of the cars don't have this sensor. So one thing that we do, we use a smartphone. Everyone has a smartphone. We have the power, right? We can collect the gyroscope data and accelerometer data and GPS data and so on. Then why can't we use it, right? So we have developed the algorithms or the models which can use the smartphone data. The problem is smartphone is not fixed. You can place it anywhere. So the orientation of the smartphone changes. So X, Y, Z axis changes. So how can we virtually reorient the smartphones and make use of this data? So we developed the algorithms for that, and we provide the based on the neural network, we develop the algorithm. We provide a kind of dashboard to someone end user. For example, okay, driver was good, his score is good. He's in terms of his speed, the driver was great. In terms of taking left turns, the driver was great. Taking right turns, driver was great. In terms of braking, driver was great. So we not only the score, we also provide a score for in each maneuvering, left turn, right turn, braking, accelerometer, and all. And not only this kind of maneuvering, but also the locations. Maybe drivers are good in the highway, but maybe not in the traffic, very high traffic area. So this all is squared. Right? Other thing is when we talk about ADAS system, we need to provide the alert to the driver, right? So we need to study the driver as well. So how the driver's mental state is also changing. Drivers might feel tense in some high traffic area, right? In some area. So we collected the data from the camera inside the car or the biometric data like the heart rate, skin temperature, stress and all. The idea is, can we investigate the driver's interaction with the vehicle, how the driver is interacting, how the driver is using steering wheel, the seat belt, how the driver is, like whether the driver is talking to the passenger, whether it is affecting its mental state, how the driver is driving in different traffic and environmental condition, and can we estimate the driver's state, mental state from this data without using any physiological sensors. So this kind of research that we've been doing. And the last that we're doing, I would explain, we want to study the driving behavior in the Indian traffic condition. The problem is we can't test our system in real world, which can risk the life of the human, right? Because we can't change and play with the different settings in real world. So one problem is like, can we create the several type traffic scenario data in the real time? Can we create in a scenario and present this scenario in the virtual reality term to the driver and put the driver on simulator and ask them to drive and capture the data and then analyze the data before putting the system in the real world, right? So this is the work which is ongoing, and we recently procured a simulator and also building this traffic simulator which can mimic the Indian traffic scenario, and then we'll conduct the experiments to evaluate the driving behavior in the different critical scenarios. We'll present the different scenarios to the driver and then collect the data. So here I will just briefly show you some very small demo or video, which will give you an idea like how we are collecting the information. So as you can see, like we're trying to, it's not as close to the Indian traffic, but we are trying to go close. For example, we are trying to put cattle on the road so that, okay, if the cow is coming, how can driver will respond, right? The auto rickshaw, we don't have auto rickshaw in developed countries. But India has auto rickshaw, which can suddenly, you can say, deviate from the route. So how it is causing the driving behavior. Some people can suddenly come to the road. How do we change our pattern, right, based on the road? So there are maybe several uncertainties. Or maybe let's say, we might have potholes. So here you can see there are potholes. So there are potholes on the road, right? So we have so many uncertainties there. So what we are trying to put, we are trying to put those Indian traffic scenarios where we might have cattle, we might have irregular behavior of the pedestrians, we might have auto rickshaw, which suddenly can take left and right turn, right? So we are trying to put these conditions in the scenario and present these conditions to the driver and collect the data and then develop the AI algorithms. So this is the work which is currently ongoing. So yeah, this was a brief, very overview of the researches globally which is going on, researches which are going on at ISC and the researches that I've been doing here. So yeah, thank you everyone. And of course, we have positions to work on this project. So if someone wants to get involved, please feel free to contact me on my social network or my professional network on LinkedIn, or they can actually email me. Thank you.
I think you have really the simulator towards the end, which you talked about. And you showed us a short demo. as to how I think that gives us a greater confidence that the research that is being done at IISc will help to resolve many of the challenges that we Bangaloreans or we Indians are facing generally. So, Professor Puneet, I will like to, because you have given an overview of the whole thing, so let us dig a little deeper. And you have set the context for the transportation revolution through AI. And but I will be starting at the lower end of the spectrum in a way, the electric vehicles, which we can see that the acceptance and introduction of the EVs is not very high across the world. From what I see, typically it is 1 to 2% in countries like USA or Japan. And only in China, they seem to have a very great focus. And EV seems to have established itself. And I think some 2018 figure was that it was almost 13% of the vehicles on the road. But in the Indian context, you did mention about charging, but what else? What are the challenges for introducing these electric vehicles, both for personal transportation, that means cars, as well as heavy vehicles for transportation of goods?
Right, right. Yeah, very nice question. So, of course, electric vehicle are the future, and of course, with electric vehicle, somehow we would be able to reduce the carbon emission or the green this gas emission significantly, right? So that's why the focus on the EVs. The problem that you mentioned, like why we're still not adopting the EVs in India, especially, right? So I guess it comes from both, I guess, the three perspectives. One is from the government side, second is the awareness, and third is the infrastructure. So when we say about, let's say, government side, so if you think about the pricing, so generally as a consumer, what we think, we compare the pricing of the vehicle that based on the fuel engine, right? The petrol, diesel, depending on that, we compare this price of this with the electric vehicle, and we found some, because of this battery, lithium battery price and the model price, somehow little bit the price of the electric vehicle is a bit high. And we see only the comparison of these prices, but we don't see the effects of this vehicle in terms of, let's say, in 5 or 10 years. Right? So maybe you will be saving a lot if you just consider electric vehicle. The first thing is the awareness. The second thing is the awareness. We don't have that awareness. As a consumer, whenever someone goes to buy this, we just compare the price of the electric vehicle and the price of the conventional vehicle that we're using. Right? We have to think the long-term effect of this. Second thing, the awareness from the government is there is no infrastructure. So we just leave the top metro city like Bangalore, Mumbai, Delhi, and Hyderabad, and maybe Chennai. Right? So we don't have infrastructure. We can find some electric charging station within the city, right? And we can use, let's say, that's why you see more sales of electric scooters compared to the electric cars. Because people generally use electric scooters for a shorter distances, and they're comfortable that even if it is running out of charge, they can go and charge it. Right? But if you think about cars, generally what we use for going for a little bit longer distances, right? With so many passengers or the people, which of course require with a little bit higher load on the vehicle, the charging might be an issue. So putting a proper charging infrastructure is one of the biggest challenges. And of course, governments are doing work, and it is also a kind of, you can say, strategic area of the government. So our Transport Minister also mentioned this before. So currently, like, it's only the 6% of the sales out of the vehicles only in the electric vehicles, but they're expecting some 25% of the vehicles on the road by 2035. So there is a target, and the trend also shows that there will be 30 to 40% of the electric vehicles will be on the road. Not just on for the person, but also on the goods side, like the electric trucks. Right? Okay. So for the goods, mainly the problem is also same. Charging infrastructure is one thing, and the second problem, like these electric trucks and for goods, they are heavily used now in industries for moving goods from one place to other place. But if you talk about intercities, right, something like that, where the distance between cities might be in like 500,000 kilometers. So we need some charging station at proper location. So, and that's where also the research is going on. How do we find where to put this charging infrastructure? Right. So we need to understand how many people are moving in which road. Okay, if there are so many people are traveling with the cars, how many charging stations to put, where to put. It all requires research as well. We can't actually randomly put anywhere, right? So it all requires research as well in that aspect. But yeah, in terms of the buying capacity or like I say buying behavior of the electric vehicles, government focus is on electric vehicles, and they're also providing some you can say rebates on the taxes if you buy electric vehicles, right? So I guess then electric vehicle is also kind of, you can say, in addition to automated vehicles and the shared mobility, electric vehicle is the future in India. Right? So I think it has its challenges, but once the infrastructure is the main challenge, once it's overcome, I guess people will be more comfortable. And of course, the awareness, we need to make the people aware, like if you think in the long term, it will give you more better benefits, both economically as well as environmentally.
But I mean, just to pick your brain, some detractors of electric vehicles say that, okay, you have replaced a internal combustion engine with a electric engine, but what is the source of that electric power you are using? That also matters as per some detractors, and therefore it is not as green as people make it out to be.
Yeah.
What is your response to that?
Yeah, it's right, Kishan. So also research is not going on like how can we just generate the electricity for these vehicles. Of course, generate electricity also requires the use of resources, and which is not a green technology. But so research is not only on this. Research, of course, how can we reduce that? So if you think about battery, which is a major component in the electric vehicle, how can we increase the lifetime of the battery? How can we increase the capacity of the battery, right? Researches are going on this. So if you think we have moved a lot in terms of research in many aspects of the like technology, sensing, GPS and all, but battery or this is one of the research area where we have not moved significantly that we should have moved like we moved in the other domains, right? So I guess that is one of the major issues, like how can we improve the capacity of the batteries? And second thing, we have to find some techniques to generate the energy in some green technology where we can generate energy which are not causing as much emission which is coming from the vehicles directly. So of course we might be using some energy which is not completely green, but if you compare the side effects, right, consequences of these vehicles, what we're using, not only the like the fuel consumption and traffic, like these emissions and so on, right? So if you compare this, of course, we are significantly saving on that part. Yeah.
So you are saying though it is much better than what it is currently with an IC engine driven or diesel engine driven concepts. This is
right.
A better option. Though
right.
we will need to still work on creating a source of basic energy, which is a little more green.
Right, exactly. And I guess your discussion reminded me one of the real scenario in India. I guess someone was using this diesel thing to generate as a generator to charge electric station. And I remember, of course, that's not a solution. The solution is to create some kind of resources where the generation is also green technology, coming from green technology. Right?
Okay.
Yeah.
That is a good call. You did mention about the driver assistance technology. And this is seems to be taking a very deep roots in the developed world. And in fact, what I was seeing was in countries like USA and Japan, this ADAS seems to be present in more than 80% of the vehicles. But in our country, it seems to be there, but only in the more premium segment. And currently, in terms of volumes, it seems to be very small, minuscule. So what do you think are the challenges in the Indian context, bringing such technology to the Indian market? And you did in the overview, you did mention about some of the benefits, but can you expand on what type of benefits will ADAS bring to the transportation sector in Indian roads?
Right. Yeah. So yeah. So firstly, ADAS systems are going to be very helpful. Uh, First thing you mentioned, like how it will benefits. Let me answer with that question first. So when you provide some feedback to the driver about their driving, right, to change or to adopt depending on the condition. For example, I'm feeling drowsy. As a human, I'm very confident that I will drive safely. But right, so if there's an alert, you can provide some alert to the driver, and if driver is taking it seriously, of course, you can save life. And I guess even if you can save one life, it's a very significant contribution, right? A benefit. Uh, so that is important benefit. But we mentioned what are the challenges in India, and are we ready for that? Right. So when we talk about, so I developed this system, like one of this that I mentioned, this driving mental states and providing driving behavior and all. So when I was at MIT, one thing I found that I was working there, I developed my model. I came to India somehow. I tried to apply the same model in India and it failed. Right. So then I thought, okay, what can be the reason and all. So let me tell you why. If you compare the transportation network or the surrounding, while in the developed countries like Europe, Australia, US, these kind of countries, we have proper infrastructure where people are following the rules, right? The proper infrastructure, no compromise on the rules, the proper lane discipline, right? Everything is there. So when you have such disciplined infrastructure or the transportation network, you are removing some uncertainties from your model, and they work well in that case, right? And that you also have it. But when you talk about India as a nation, we can't prevent someone wave the hands. They suddenly change their trajectory, right? So we have so many heterogeneous vehicles. Like other countries, we have auto rickshaw, we have cycles, we have trucks, we have tempo. We have so many heterogeneous vehicles. We are not just have 2 or 3 vehicles. And each vehicle has different dynamics. Based on their maneuvering capacity and all, right? So we have so much heterogeneity. And first is the infrastructure. We have road holes, road bumps, we have potholes, we have uneven road surfaces, right? Suddenly on the highway we have a speed breaker. So many things which we have different compared to the developed countries. And then we have lane disciplines. Do we follow all the traffic rules? Do you follow safe distance between the vehicles? Do you follow the lane changing? Do you follow roundabout, how to take the left and right turn and all? So of course we are compromising on most of these parts, and that brings the challenges. So if we say, is the ADAS successful? Of course, there are many challenges in India, especially to develop this kind of ADAS system. And even if we develop, for example, let me tell you an example. I was talking to, when I was here, I was talking to someone. So many insurance company in India, they put one small device in the car, which can alert the driver if they are driving unsafe. For example, suddenly they're over speeding or suddenly putting the brakes, there will be some alert, right? And this alert basically also for the insurance company so that they know who is driving good, and so they can give some bonus or some kind of discount on the premium, and some who are not driving good, they can increase their premium for the insurance. What people do, they don't take it as a lightly, and they remove this board as soon as they get this board, and they just disconnect it and they're driving. So when we are not aware, when we don't want to use this kind of systems, ADAS can be successful, right? So first thing, awareness. We have to be aware about the system, how it is going to be helpful. Second thing, in what way we have to provide the information. So we talk about 20, 30 years back when we had a simple car, steering, that's it. We talk about distraction, but we put more sensors, more console boards, so many things inside the car. Now they are also distracting the driver. They are putting so many things inside the car as well, right? So it is good in terms of driving, but somehow it is also causing some kind of distractions to the driver. When you put music system, TV, so many things are putting inside the car, right? So we are also distracting the driver. So one thing, how we study the drivers based on ADAS. So for example, one study that we are doing here, let's say we provide the alert. How sincere or how carefully the driver considers those alerts, whether he or she is serious about the alerts or not, or they just ignore it. Okay, I'm getting some alerts, I don't care about the alerts. Right? So this study is important. So how, in what aspects you have to give alert? Do you have to give the visual alerts, or do you have to give some sound alerts, or some haptic alerts? So these all require studies in what format you have to give alerts, so the drivers, the driving is also not distracted, and they also get some alerts, and they can change the driving, right? So awareness is one thing. In ADAS system, I guess the challenge is that what we have to study the behavior of the people in India. So that's why the simulator that we show. First, we have to study how the drivers in India are driving in these conditions, and then we have to develop a system accordingly. And we can't directly go to this advanced system where we talk about lane change, where we don't have proper lane marking in our roads. So we can't talk about lane change in India, right? So, but for example, collision avoidance, braking, assistive braking, there are already some vehicles which can help you to put brake, cruise control, what we talk about, right? So we also have the parking, which can assist you parking by giving some full 360-degree of view, right, around the car, and you can park it better compared to the previous case where you have some blind spots, right? So they are helping us, and I think if we study more about the driver, how they are interacting with these vehicles or the surrounding conditions, how they are responding to these alerts that we are providing through the ADAS, I guess these studies will help us to make it more effective ADAS systems in India.
Right.
Yeah.
In fact, when the seatbelt rule came, the seatbelt warning itself is, I think, a very low level of ADAS only. But
so people see, awareness is the first thing. People use seatbelt, and I saw in my close relative also, they put seatbelt, and what they do, they put seatbelt from the behind and just connect it so that there is no alarm. So we have seen this cases, and so if there is no awareness, of course, ADAS systems won't be useful. So awareness is the one thing we should be serious about. By safety, by life of the people, not our life, but also the passengers' life or the pedestrian life, who are on the road.
In fact, probably this Cyrus Mistry case has woken up people, and at least they're, I think, more vigilant about putting the seatbelt on. Maybe.
Yeah. So as I mentioned, the government policy should also be there. For example, most of the scooters come with the headlight always on. They can't turn it off. So now government is trying putting some regulations. Okay, you should have at least this much capacity or intelligence in your vehicle, right? So I guess government side also some policy should come, so that people, also the penalty. If you are not following the rules, the penalty should be huge in that aspect.
Right. So I think you summed it up very well, that governmental policies and directions is an important first step, but also awareness about the significance or importance are also very important, apart from providing infrastructure itself.
Infrastructure is also, as I said, government's role is huge there, by improving the infrastructure.
Yeah. Very good. So if I may, you did mention about the autonomous vehicles, which General Motors started way back in the 50s. So seems to be that this autonomous self-driving cars seems to be very rapidly progressing in the more developed countries. And though in its full glory, as you said, level 5 is yet to be seen even in the developed economies, it is projected that if not level 5, maybe level 4 level will be reached by 12% of cars in countries like USA and Japan would be autonomous, as per some study that I had seen. But as you also have been saying repeatedly, considering the general chaos on the Indian roads, and you gave us such a nice video of cows and auto rickshaws and jaywalkers, potholes. So do you think autonomous vehicles, especially level 4 and 5, will ever hit Indian roads? What do you think are the challenges that you foresee? And of course, benefits.
So I would say level 4 and level 4 is also, at least we need a decade to go to the level 4. If we talk about on the road. Level 5, of course, even in the developed countries, they have not reached to the level 5 autonomy, and they are talking level 5 in a decade time, right? So although like the Tesla, Elon Musk has mentioned, like they are targeting 2030 to put the first level 5 vehicle, but I guess that's still we are far from there. So, but level 4, if you talk about in general, like in globally, level 4, I guess Waymo is the first company who put the vehicle with the level 4 with just intervention for the driver only in the emergency situation. But that is only from in a very controlled setting with a proper, very good weather condition and all. Still not in ambient conditions what we see in different kinds of adverse conditions, with very like in low traffic and all. So I would say level 3 is achievable in India, where only in some certain road segments. Of course, we can't talk about this highly traffic area or the street, streetways and all. But in the highways, there are some where we can reach to the level 3 with, of course, with the human intervention. We require human, but there are some cruise control, for example, where you just need to sit and then just see how they're going. So level, I guess most of the automobile company in India, I guess, then they say autonomous vehicles. So the level 1 and level 2 is already there, where they can just put hands off and then it can take some steering left and right. So it can also put the brake and all. So level and level 2, of course, is there. But also, if you talk about the high traffic area in India, or if you talk about the highly stochastic conditions, like with so many uncertainties in India, we can't think about even level 2 or level 1. Right? So there are challenges, but if hopeful we were like smartphone, as I keep giving the example. We didn't when we for example, I was doing my engineering, we had this very small phone, Nokia 1100, and then we never thought that someday I would be able to talk some people in US in real time and converse with them. So we never thought about this, but it is possible, and now we are doing it. So maybe in some proper control setting with some regulation and initiative from the government, we might see on a dedicated channel, maybe we might see this fully automated vehicle. But this may be possible only on some dedicated channel where no distractions or not very proper control settings only you can see. I see maybe next 20, 30 years, the human will be integral part of the vehicles and they are not going anywhere, like in terms of my understanding. Yeah.
Thank you. Thank you. Yeah, you gave a excellent intro to ITS, Intelligent Transportation Systems. But as you also mentioned, indicated that ITS is a combo of both information and communication technologies, which can then be applied to traffic management and help to integrate 3 key factors. One is the infrastructure, then you have the vehicles, then you have the users who are using those vehicles. So, and as you had also indicated, the success of ITS will depend on a seamless communication between these 3 players. So one doubt which comes in everyone's mind is that my data or my personal data or privacy to which I have a right, why will I let go my privacy of my data to make life better for others? So this type of, unless one solves this problem, this type of transportation revolution that you have been indicating may never happen. So what is the way forward, Professor Puneet?
Yeah, so as you rightly said, like the ITS is basically a combination of the infrastructure, like infrastructure and the algorithms which involve the road infrastructure, vehicles, and the users all together, right? They bind it together. So as you actually said, when you talk about AI models, they are data hungry and they want data. And where do we get the data? We get the data from the vehicle and from the users, right? So some data which are with the government or the city councils, government can share this data with the people who are interested to analyze the data and can make use of this data. Right? But the data from individuals, right? For example, I am the driving, and whether I'm ready to share my data, how I'm driving, right? Whether I'm comfortable or not. So of course, in some way, for example, you're using this Uber, Ola, or different kind of ride-hailing services. You are sharing the data, and since I work with the Grape, which is again kind of company in Singapore, Southeast Asia, you're giving them you are all the data like your accelerometer, gyroscope, GPS, all the information you're giving somehow. Of course, they are not sharing it, but the data is there. So we are giving them permissions to use the data, but can we say our data is secure or private? Right, that is the first thing. The security of the data, the privacy of the data is major concern, not only in the ITs but also in major most of these problems where AI is being used, where the data is, where we have data, right? So first thing, there should be a proper infrastructure where we can allow people to share the data. So people must have confidence. For example, we talk about the healthcare, where it is very important. The privacy of the data is very, very important. Similar type of the protocols, standardization, and the infrastructure should be there, where the model, so it can come from two perspectives. One perspective is from the infrastructure. That means you create a kind of a system where you can allow people to share the data by without revealing their identity. You can anonymize their identity, right?
Nice.
And of course, you can claim it. Okay, we did it. We are not using data, but there should be confidence from the people. Okay, you are doing it. We say your Aadhaar card information is private, but who knows people are using it, right? So first thing, the confidence of the people should be there. So the trust and confidence, and so that is also very important research in machine learning, right? So the trust, ethics, and fairness of the models as well as the data, and the privacy and security issues. So one thing, as I mentioned, is the infrastructure. We need to create an infrastructure where people can share data. And why do I share data? Am I getting some incentives? So one thing is a public awareness, you can share data. One thing, there should be also proper incentive-based scheme where people should be encouraged to share the data. If they are given some incentive, maybe let's say we might give some incentive in terms of the taxes or sometimes of using government services. There can be some government initiatives, some policies, some yojanas. So there should be some incentives for those government initiatives, which can encourage people, citizens, to engage with this infrastructure and share the data. Right? So engagement is one thing, but apart from the privacy is another issue, and we need to take the confidence. We need to build the confidence. So we need to create the infrastructure, and that's where also machine, this AI focus is there. Like, how can we secure the information of the people? How can we anonymize the information from the people? How can we create we can process the data privately without even if we, let's say, change the data in some, we can perturb the data so that the data has the same information, what is to be there, but there is no identity information now. Right. Can we get the same analysis now, which is changed now? So researchers are doing, people might know about the federated learning, privacy preserving learning. So there are researches going on domain, how can we secure, right? The edge computing as well is one of the top area where we don't need to share data with everyone. We can just share data with the local devices and just get our analytics. So of course, researchers in IT is also being done. How can we secure and process data in a secure and private manner? Yeah.
Actually, to sum up what you said, it looks like you are saying the three mantras is build trust in the system, then randomize the data so that no individual specifically highlighted, and create incentives for the individuals to share so that overall
right. So that's very nice example. Like in many countries, if you especially in Europe, there is a city like Smart Santander, and there are also many protocols, many cities like which created the test bed and applications where they involve citizens. So it is called participatory sensing or the crowdsourcing kind of crowd sensing, where people can share data and they are in return they are getting incentives for that, right? For example, if Google recently required Waze, company Waze, where Waze you can provide information about the real-time traffic. If there's some accidents or some road closure, you can just click the photo and put there, and you get some points. Like you get points from the Paytm when you spend something. So similarly, there should be some system, incentive system where people are encouraged to share their data, of course, in some controlled and private manner. Yeah.
I see. Yes. Okay. Wonderful. One last question from my side, because there is a huge number of questions from the audience. So one of the points I wanted to explore with you was regarding the the basically about the human aspects. So while using advanced software systems, the human issues many times, of course, they are always very important. But many times you see that these software systems do not consider the abilities or inabilities or the special characteristics of the users, diverse users. So what do you think is a right approach in the design of such? Because as the software is becoming more and more complex. So what do you think, what is your advice in terms of making it more human-centric softwares?
Yeah. So, of course, for any developing for any policies, like let alone software with there, but even for policies, let's say government wants to put some policy for transportation, they want to put some, let's say, metro station, right? So before putting any metro station, you should know where to put it. So for that, you need to know the people. Okay, if you put what is the social characteristics of the people, what is the demographics there, what is the economical factor there, like what is the their property of the people in the economically, whether the sound. So of course we have different geographically and demographical factors in India in terms of socio-economic factor, right? So these all aspects would be considered. Then uh, let them create the policy depending on that. For example, let me tell you one thing. We have ticketing system in India, right? So when I came to Bangalore, went to metro station, and we have this proper this you can say what they call tokens, right? This round ones where tax smart tax. So we have to go to the station, the particular station, ticket station. We have to pay in terms of maybe UPI or whatever, and then we get the ticket and we put it there. But sometimes in the peak time, we might have queue there, right? So when we or maybe in some stations, I thought there is no proper accessibility thing, like for even physically disabled people or the older people, right? Kind of assisted mobility, we call it. So first thing, if there is a queue, are we considering like all the people have to use this? Can we reduce the queue in this kind of station? So first thing, we have smartphones, right? We using UPI. Can't we create a mobile phone to put on the device directly and just use without buying a ticket? We just use smartphones and then just put it on the machine, tap it, and then just go. We are paying it, right? So we can make use of this technology. When I say human-centric issue, human-centric, not everyone knows mobile phones, not everyone knows, using this tech, not everyone brings the case. So we have different types of people in India. So we should have diverse options on the network so that we can create a smooth flow in terms of traffic and mobility. Second thing, so let's say we should also know most of the humans, we have certain, I can say, most of the times we have dedicated route or mobility patterns. For example, many of us go from our house to the office, house to the office, and office to the house, our home, right? Most of these are the mobility patterns. And sometimes we also go to the nearest shopping center or movie theater. So they are the nearest gyms or schools, hospitals. These are. So we have some kind of certain mobility behaviors, right? And for each area, we know this data. So this data should be used. Okay, if this is a requirement, which kind of mobility solution I should provide to the people, right? Where to put the station. So people's information should also be considered. Of course, government consider in terms of survey, but now since we have data, we have to make use of this data. Second thing, assistiveness. We don't have proper pedestrian, you can say, pathway, right? Or kinds of footpath, dedicated channel for the pedestrians. Even if we have, we can see motorcycles also going in that particular way, right? So on the sideways. So this is also mobility. That's called based on walking, right? Of course, non-motorized mobility, but that is also mobility and transportation. So that will also be there. So how can we encourage bicycles? For example, as I mentioned, first mile and last mile. How can we encourage walking? Because it is not only causing us it is reducing the emission, but also it is giving you health benefits, right? In terms of when you're active. So I guess these all factors should be considered. And when we talk about algorithms and AI, there's already human bias in most of the algorithms. So we should also consider the different human factors so that we can remove those biases from the technique. So the social factors, the economic factors, the demographic factors, these all should be considered when we are developing a policy or a solutions for the people.
Right.
Because it is for the people, so we have to consider the people for developing the this kind of policies. Yeah.
Thank you. I think that's a wonderful summary. Now, there are many questions, but we'll be able to take a few. One very generic question is about the blockchain, whether this technology can be used to resolve some of the issues of transportation or logistics, basically on the safety or security aspects of privacy aspects also. What do you think?
Can you just repeat this question again?
Can a blockchain be used to resolve?
Blockchain.
Yes.
Yeah, I guess I missed this technology, blockchain. So of course, blockchain will also have a huge role in a privacy aspect, right? Or maybe making the analysis decentralized, right? So
Yes.
of course, the blockchain technology itself has huge potential, not only in the transportation, but also in healthcare, smart cities, where we want to process the data in a decentralized manner you can say while securing the information, right? So I guess blockchain has a huge potential in the ITS, not only the ITS, but also in healthcare or any domain where we have data, so that we can somehow hide the identity of the people while floating the information, and also we can process data in terms of blocks, so that in terms of a chain of blocks, what we do in this technology, and while securing the information. People are proposing some kind of they've come with some kind of framework or infrastructure, but still we don't have that that kind of skills or the knowledge to put that to that in a real world. So now many industries are focusing on the blockchain, that I am aware, but to put them in the real system, like for example healthcare or the ITS, I guess it requires more skills and more technical expertise to develop this kind of system. But I completely agree. I guess blockchain will play a huge role to process the data or to enable the transaction in a decentralized manner. Yeah. Even for ticketing, like ticket buying, I guess this also be solved there. Yeah.
In fact, nowadays in the airports, you don't need a physical copy of the boarding pass in many airports. You can download the boarding pass and use a scanner and keep going.
Yeah. Right.
So metro also should follow.
Actually, the good thing about India is like there's a revolution going on. We have digital revolution, right? We have so many very good digital infrastructure, and the good thing, once we start make use of this infrastructure, it can enable so many good applications in various domains. The major problem is how do we enable the sharing of the data among different parties which are in silos. So how can we enable this sharing the data among the parties? So that's a very important problem. Yeah.
Another set of questions is, I mean, that means you means in IASC and yourself, are you working with local governments to address any specific problems in Namma Uru, Bengaluru?
Yeah, we are working not only with Bangalore, but also in other cities as well. So we are working with BMTC. So even myself is also working on BMTC. So also KSRTC. So what we are doing, two things. First, we are collecting the data about basically these buses, because when you say driving safety or behavior, bicycles is one thing, but if they don't drive well, they are unsafe driver, they may cause only few lives there and some more on the road. But the vehicle which are like bus, which carries so many passengers, very heavy, and many people use public transportation in India. the focus, what you're doing is a focus on this public transportation, heavy vehicles. So what we did, we collaborated with BMTC and we are putting the sensors, the cameras in front of the BMTC buses, inside the buses. Of course, we are making sure this privacy concern. We are, hiding the face of the driver. So in a way, it is being captured in that way. So we are collecting data and we are capturing the data in different road corridors, dedicated corridors, because we can't directly put in all the corridors. So we have Bangalore to Chennai, one corridor, one highway, and within the city as well, there are some certain segments where we are collecting the data real time. And then what we are planning to understand the driver's behavior, the pedestrian's behavior, the quality of the road infrastructure surrounding, right, and the condition of the infrastructure, as well as traffic flow, right? So this all information we are collecting. We have cameras, we have lidars, we have this GPS accelerometers. So we are collecting so much sensor data. And also recently we are going to collaborate with the BMTC to put a sensing board. So I was working on this at MIT, and similarly I developed one sensing board here as well. So where we have sensing board, which is a magnet mount. So we just plug and play. You just put on the top and just detach it. So it's not like you need a screwdriver. So it has multiple sensors. So it has air quality, not only PM 2.5, PM 10, and also CO2, NO2. It has noise making. It can also create the noise. It has Bluetooth and the Wi-Fi scanner to somehow estimate the crowd density at different level. We have 4 directional cameras, all the 4 angles. We have LiDAR, we have ultrasonic sensors. So we are collecting huge amount of data. So the objective is first to create the profile of the road, to understand the driving behavior of your own vehicle, like what we call ego vehicle and the surrounding vehicle, and enable the analytics. For example, how the driver should drive, pedestrian behavior, what are the areas where we have huge traffic or huge people or the crowd. So this kind of insights maybe is going to be very useful for the government. And of course, one is the information from the data, and one is the technique, which can be helpful, like surveillance, right? So we are providing so much, we are collecting the data, and this. So one of the problems that we are solving is the reduce the traffic congestion, which is the very serious problem in the Bangalore. So even if we can divert, or you can say 10% of the traffic from the peak this highly traffic congested location at the peak time, it is going to be huge impact. And similarly for traffic safety, if somehow we are losing 150,000 lives every year because of the human error, 90% of the accidents are because of the human. So somehow if we can create this kind of ADAS systems and give some alerts to the driver and train them using the simulator. And even if we can reduce the 1% of the life, I guess it's going to be a huge impact. So that's our focus, and we are working with the BMTC and KSRTC, and we are also engaged with the who's very also interested in transportation, especially in Bangalore.
Wonderful. Just there are other questions, but I think we will request them to post it to you, because you have kindly agreed to.
Yeah, I guess I'm very happy. Like if they want to reach out to me, they can just write an email. They can come to the LinkedIn and write an email, and or they can come to ISC and meet me. Yeah.
So kind of you. Very nice. One last question, which is not directly related with the topic, but indirectly. It says, can AI be used, or how can AI be used in rescue operations during or after disasters? Slightly different question.
No, I guess that's a very nice question. So one thing I guess I did not mention. So when we talk about future technique or some like technology, nowadays, if you don't believe, even like many of us don't believe. So when we try to reduce the congestion in the Bangalore, one of the solution is to introduce the flying cars. Right? Flying car is by, of course, it looks like that miracle or unimaginable, but there is a research going on, and I guess Germany also have done it. They have proper dedicated jet-based flying taxis where you can transfer people from one place to other people. Similarly, the research at IS, even at IS, research going on the flying cars where we can move people from one place to other place. All right. So of course, with some legislation, some rules, and kind of policy, this can be possible. So in terms of these disasters and all, one very important technique is the robotics and in UAVs. So in our center, Robot Boss Center for Systems, we are working on these applications for, especially for the disaster management, and like there's some fire in forest or some, some fire in a building. How can we use these autonomous systems? So one can be autonomous, one can be remotely operated vehicles like drones, where we can remotely operate it and they can do the task, right? So and one can be like robot, of course. So I guess robotics and the UAVs are playing huge role in not just micro, but also like very huge UAVs where they can carry, where the payload capacity is like for the human, and they can be used in rescue operation. I guess in many countries also, maybe India also somewhere, not for the rescuing, but also for some monitoring in this kind of, there's disasters. UAVs are being used, and also in many countries they also use drones to carry the human from one place to that place. So I guess UAVs and the UAVs and this robotics plays a huge role in this kinds of system, because we are not risking life. It's just of course robots, but how we give them intelligence, where to go, how we coordinate them. So this requires AI. So I guess robotics and UAVs with proper AI can be used in the scenarios.
Wonderful. So thank you again, Dr. Punit, for really enlightening topic, and from the, as I said, tsunami of questions that I have got, it looks like you have really touched the audience very deeply, and I appreciate your coming this evening to MIJSC's webinar series, and we look forward to continued association with this Center of Excellence, and we can hopefully the technology and the management sides can cooperate to create something very new.
Definitely, and as I mentioned, like if anyone is interested in collaborating and working with us, both on a research level or the collaborative level, I guess feel free to come and contact me. We have positions, and we are happy to collaborate, and work together. Of course, in a better AI for good, right? What we call it. So if we can save some life, yeah.
Sabka Vikas.
Exactly. Yeah.
Thank you.